In this video, I will be discussing how to graph polar equations. But before anything else, allow me to answer the question, why do we study polar equations? We study polar equations because it's an easier way to represent some of the common graphs that we see in mathematics. Actually, sometimes this is a cool way of representing some curves, common curves we see in mathematics. For example, suppose we want to represent a circle of radius 3. At this time, we don't need the very usual fancy formula in representing a circle, which involves the x and the y and its center together with its radius. Here in polar equations, we just say r is equal to 3. So that equation is already an equation of a circle in polar form. Now, that circle is a circle whose center is at the point of origin but of radius 3. So if you want to sketch the graph of that circle, the center is at the point of origin here. And you move 3 units to the right, also 3 units upward, and then 3 units to the left there, and then also 3 units downward. And then you can actually sketch the graph of the circle like this one here. So that's a circle of radius 3. And I can show to you that this is really a circle when I will be converting this polar equation to its corresponding rectangular equation. So to convert this one to its equivalent rectangular equation, we must recall our formula that we derived in the previous videos, that r is equal to the square root of x squared plus y squared, and theta is equal to the arctangent of y over x. So this r, this equation, I can square both sides and say r squared is equal to x squared plus y squared here. So converting this one to its equivalent rectangular equation, we have our r, we know the value is this. So instead of writing r, we will substitute its value, which is square root of x squared plus y squared, and this is equal to 3. But if I square both sides of this equation, so I will square this square root of x squared plus y squared, and also square the right side, which is 3, I will get the square of this as x squared plus y squared, which is equal to 3 squared. And you can see that this is an equation of a circle of radius 3. And you can see that our polar equation of this rectangular equation is just very simple compared to its equivalent rectangular equation. So this is a cool way of representing a circle through an equation. Another example is when we have here theta, which is equal to pi over 3. This one is already a polar equation, and actually the graph of this is a straight line. It's a straight line that passes through the point of origin. So here, and this line makes an angle from the positive x-axis by pi over 3. And to prove to you that this is a polar equation of a straight line, which makes an angle of inclination from the x-axis of pi over 3, I can convert this one to its equivalent rectangular equation. So here I can write again theta, which is equal to pi over 3. And we know the value of theta, that theta is the arctangent of y over x. So instead of writing theta, I will write here the arctangent of y over x, which is equal to pi over 3. And if I'll take the tangent function of both sides of the equation, so I will have tangent of the arctangent of y over x, I will have also to take the tangent of the right side, which is pi over 3. And you know from your trigonometry that tangent and arctangent are inverses to one another, so it cancels to each other. So what will remain is y over x, and this is equal to the tangent of pi over 3. And you know from your trigonometry that the tangent of pi over 3 is equal to square root of 3 over 1. And multiplying both sides of the equation by x, we have y, which is equal to the square root of 3x. And you see that this is a rectangular equation of a straight line with slope square root of 3 and the y-intercept of 0, so therefore it passes through the point of origin. So number 3, we have here, suppose our r is less than 3 but greater than or equal to 2. So what is the graph of this inequality? The graph of this, I can tell you in advance that it's a family of circles. And you will see that the graph of this is a family of circles whose radius is less than 3 but greater than or equal to 2. So if you sketch the graph of that, you will first sketch the graph of a circle whose radius is 2 here. So you move 2 units upward, 2 units to the right, and 2 units downward, and also 2 units to the left, and then you connect this one to form a circle. And also you will move 3 units upward, 3 units downward, 3 units to the right, and 3 units to the left, and then connect also this one to form a circle of radius 3. So the graph of this is this one. So I will shade here, this one. So the graph of this is a set of circles whose radius is less than 3 but greater than 2. So it's a set of circles, a family of circles. And you can observe that at the circle of radius 3, it's a broken line, which means that this circle of radius 3 is not included in this graph. Why? Because you can see here that this is a strict inequality. So the radius of 3 is not included, but the radius of 2 is included here. So the graph of this one is this. So this is a family of circles there. So what if I will have here this one, our r, the radius is less than or equal to 2 but greater than or equal to negative 2. But our angle here, theta, is less than or equal to pi over 4 but greater than or equal to negative pi over 4. So what is the graph of this one? First, let us graph this angle, the angle of pi over 4. So the angle of pi over 4 is half of the angle of pi over 2. So this one here is the angle of pi over 4. So this is a straight line which passes through the origin and makes an angle of inclination of pi over 4. So this is our pi over 4. Also, we can draw this straight line. This is a straight line that is also passing through the point of origin, but it's sloping downward because this one is having an angle of negative pi over 4. But take note that our radius is from negative 2 to 2. So let's start a radius of 2. So having a radius of 2 is here. So this one is part of the graph. So all of this here is part of the graph because your radius spans from 0 to 2. And not only that, from 0 to negative 2. Also, in the opposite direction, you can find here the symmetrical shape of the right part. So the graph of this is like two fans that are opposite to each other. So number 5, suppose we have here a polar equation r is equal to 3 cosecant of theta. What is the graph of this? So if you are not an experienced person in polar equations, you cannot easily decipher that the graph of this is a straight line. And in fact, this is a horizontal line of distance 3 units from the x-axis. So the graph of that is a straight line, which is 3 units above the x-axis. That one. So this is the graph of this one. And to show to you that this is a graph of a horizontal line which is 3 units above the horizontal axis, I can convert this polar equation to its equivalent rectangular equation. And if I will write here r is equal to 3 cosecant of theta, I can apply the knowledge which we've learned from our trigonometry that cosecant theta is equal to 1 over sine theta. And then if I will multiply the 2, I will have 3 over sine theta. And if I multiply both sides of the equation by sine theta, the sine theta at the right, which is in the denominator, will be cancelled. And we know that the value of r sine theta is y. So y is equal to 3. And you can see that this is a rectangular equation of a horizontal line which is 3 units above the x-axis. So at this point, suppose we are asked to sketch the graph of this polar equation, r equals 1 plus sine of theta over 2, where theta is greater than or equal to 0 but less than or equal to 4 pi in the xy plane. So first, let us see the graph of the basic function sine theta. And you may recall from your trigonometry the graph of sine theta. So if you plot this one here, allowing theta in this axis, and then our y here, we know from your trigonometry that it has a period of 2 pi. And it starts from 0, but the amplitude is 1. So it goes this one here, and then back to 0, and then negative 1, then 0. So this is one period of the graph. So at this point, this is when your theta is pi. So here at the highest point, this is where your theta is pi over 2. And also this one, this is 3 halves pi. So using this knowledge in trigonometry, we can say that in the r theta plane, the graph of this one is almost the same to the graph of this, but since there is a 2 in the denominator of theta, the one period of this graph is being stretched to twice of this period. So the period of this sine theta over 2 is not anymore 2 pi, but it's 4 pi. It is being doubled here. So if this is 4 pi, this must be 2 pi here. So in between, we have here 3 pi. And of course, in between 0 and 2 pi is pi. So the graph of sine theta over 2 is being stretched to twice of the period of this graph. But as you can see in the polar equation, there is a 1 here, which means that the graph is being translated 1 unit upward. So instead of having a 1 here, you will move 1 unit upward. So the graph will not start at 0, but starts at 1. And then it goes up here to its amplitude of 1. So following this basic graph, here it goes back to 1. But in the original, it goes back to 0. And then to negative 1, but here to 0. And then back again to 1. So if you connect this graph, you will have the graph of like this. So this is the graph when there is a vertical translation of the graph to 1 unit upward, and it is being stretched to twice from the basic graph because of the number 2 in the denominator here. So how can we use the graph of this one in the r theta plane to graph this one in the xy plane? Thus, in the xy plane, we have our theta here is not anymore in this axis, but the theta here is the angle that revolves in a counterclockwise direction. And the r is the radius, it's the length of the radius of the graph. So at angle 0, the radius is 1. So at the angle of 0, we'll have here 1. So it starts here. So let's scale this graph. So we have here 1, 2. And then moving downward, we have here negative 1, negative 2. And then we have also here 1, 2. Negative 1. Then we have negative 2. And moving upward, also we have 1 and then 2. So when your theta is 0, it's 1. But as you can see, as the theta moves from 0 to pi, the height increases from 1 to 2. So when the angle is 0, it's 1, but it increases to 2 when it reaches the angle of pi. So this is our pi. So how can we graph that one? So the graph is not a circle because the radius increases. So suppose I am in this angle, it's not anymore 1, but it's greater than 1. So it increases here from this one. And then it reaches negative 2. So the radius is 2 when the angle is pi. And then as you can see, from pi to 2 pi, the height decreases from 2 to 1. So here, from pi to 2 pi, the radius decreases from 2 to 1. So it has the same behavior from 0 to pi. But the only thing, it's not increasing, but it's decreasing here. So from 2 to 1. And then as it moves from 2 pi to 3 pi, the radius is from 1 to 0. So again, this is our 2 pi, and then you move to your 3 pi. So the radius is from 1 and then moves smaller to 0 here. So look at the radius. The radius is 1, but it continues to decrease as the angle theta moves from 2 pi to 3 pi. So when it reaches to 3 pi, it becomes 0. And then as it moves from 3 pi to 4 pi, the radius increases from 0 to 1. So here, let's move from 3 pi to 4 pi this time. So from 3 pi to 4 pi, the radius increases from 0 to 1. So this is how the graph of r, which is equal to 1 plus sine of theta over 2 looks like. It starts from 1 and then moves in a counterclockwise direction. So from 0 to pi, it increases from 1 to 2 there. And then from pi to 2 pi, it decreases from 2 to 1. So here. So from 2 pi to 3 pi, it continues to decrease from 1 to 0. So here, from 1, the radius is 1, and then until it becomes 0 here. And then from 3 pi to 4 pi, it increases from 0 to 1. So again, it goes back to 1 from 3 pi to 4 pi. So this is the graph of this polar equation. If you learned something today, please check out my channel for more videos like this and click subscribe. Click the notification bell below so you'll get notified whenever I'll be posting a new video. Don't forget to like this video to show your support. And always remember to math your way up. Thank you.